Yeah, that's what I hear is the plan.
Yeah. I spoke to him yesterday, day before. He's very much up for coming on board tonight, so hope you will see him.
That's a good thing. It was funny, rather ironic. I had a problem with my YouTube app, and so I ended up clearing my viewing history just yesterday. And subsequently, I had left YouTube running, and the next video that it pulled up at random was his install video.
Wow.
And so it was. I'd seen it once before, but it was always nice to see that. So it was an opportune chance to review his install.
Of course, and obviously they love what we've done, and obviously that made them be able to stay off grid for so long.
Pardon me, what did you say?
I said because of the batteries, obviously they were able to stay isolated for so long. So it's great for them to be totally independent off grid while the virus was going on.
Yeah.
Nice view behind you.
Yeah, that's a little village up in the Swiss Alps. I was there last weekend. So, okay, so we are getting most of the people here. Make sure I get my recording on, and so that is good. Okay, well, where is Bill? Okay, and there's Jesse, getting Jesse in there, and Brian. Okay, so good to see that we've got.
Okay, back.
Okay, so here you are, and Bill, I'm going to make.
Hi, Jesse.
Hey. Hi, Jess.
Okay. Oh, Jesse is muted, so.
There we go.
There you go. Okay.
How you doing?
Doing good.
We're doing good. And Justin's still with us. Good. So do you want to pop up that first slide and we'll get started? I think it's
here we go.
Okay, I want to thank everybody for joining us today. I think it's a very important subject that we're going to talk about. And of course, it's been sort of a moving target, but some Amel owners have converted to lithium storage, and others are of course thinking about it. There is a company in Nevada by the name of Dragonfly that makes lithium batteries. They sell them under the name, or they have another company that markets those batteries by the name of Battleborn batteries. And that's the brand name that is just about everywhere except Europe. And in Europe, the distributor of the same battery, the same lithium battery made by Dragonfly, is Transporter Energy. Now, the good thing for all of us is both Battleborn and Transporter are large Victron distributors and can offer usually more attractive pricing on Victron products than just about anywhere else that you're going to find it. So they're a good source for Victron alone, but obviously the subject of the meeting today is the lithium batteries. The presentation is going to be given by Jesse, who I see is ready to go. Jesse is with Dragonfly Energy and Battleborn in Nevada in the United States. Also on this call is Justin Richardson. He's the founder of Transporter Energy in the UK and distributes the same batteries that we're going to be talking about throughout Europe. And again, is also a large distributor of Victron Energy. So also joining us is Brian from Delos. Is Brian?
He's here. Yeah, he's here.
Mm-hmm. Oh, okay. Hey, Brian, how are you? And I'm hoping that Brian will be available for questions in the end because, of course, Brian has Super Maramoo Delos with all of these nice batteries and systems installed. So I'd like to turn it over to Jesse. Jesse has a presentation for us on the batteries. Jesse, you ready?
I am ready.
All right.
Let's see here. Switch this over real quick here. All right. So can you guys see the screen? Can you see the presentation?
Yeah,
yeah,
it looks great.
Great. All right, guys. Well, thanks for having me. Really appreciate it. It's good to see all you guys. Justin over there, haven't seen you in a while. And we're going to go over the Battleborn lithium-ion drop-in replacements. As I mentioned, we're a company out of Reno, Sparks, Nevada. Dragonfly Energy, Battleborn batteries, basically the same company. We make OEM batteries in the Dragonfly range, and the Battleborn is mostly our consumer brand. So it's very popular, very well known, very good battery. We also sell that same relabeled battery over to Transporter Energy, and they're in, of course, Europe, as most of you know. So, all right. Some of you will know this information, some of you won't. It'll be new or relatively the same, but we're going to go over some of these things. So what is considered a drop-in replacement? What's the compatibility? What causes some of these lithium batteries to fail? And what kind of variation there is in the cell quality out there? A lot of people don't realize that there's many different varieties of quality when you're talking about lithium ion or lithium iron phosphate in general. How to prevent failures in batteries, the BMS systems and the importance internally in a battery, why LiFePO4 or lithium iron phosphate is better than lead acid, charge rates, stages, and how it fits into existing systems. So what is a drop-in replacement? You get asked that a lot. A lot of people are under the assumption that they take out their battery, drop it in, and everything is perfect. In a lot of cases, it does work great, but charging them can be a little bit different since this is a higher voltage battery. But basically, a 12 or 24 volt lithium battery works really well within a 12 volt or higher system, and they work really well with the appliances that are found in most marine applications. RV, marine, off-grid, a lot of these are used as such. So the main type that are used in our drop-in replacements are the LiFePO4. Again, lithium iron phosphate or LFP, which you've heard of as well, I'm sure. And that's going to be the focus of our presentation. So compatibility. Why is this lithium iron phosphate so compatible for marine and other applications like RVs and off-grids? So the nominal voltage of LiFePO4 battery aligns really well with the systems that are already in these applications. If you look at, let's say, a 12 volt battery, each cell is 3.2 volts. And so that makes that nominal voltage 12.8, which is perfect for these systems. You know, if you have two 12 volt batteries and you run them in series, you're going to get the 24 volts, which is great for those systems. And on that, you can run them up to 48 volts in these systems without any kind of issues, the BMS will handle that really nicely. So thermal safety, and well, actually, let's look at the long life cycle on the top here. So this is kind of interesting. If you're looking at a standard lead acid battery, that first line that drops pretty viciously, it's about 500 cycles if you're lucky and you take really good care of those batteries. And it just kind of drops off the more that you use it. Up on the top there, that curve, that cycle life is in the 5,000s. And that is 10 times as long as a standard lead acid battery, as a lot of you guys have heard and are familiar with. Now let's just put that into perspective for a second here. Let's say you were to discharge our battery down to completely empty, 0%, which you can do. You can't do that with a standard lead acid battery unless you really want to destroy it. As a matter of fact, if you go under 50% of the capacity of lead acid, you have a tendency to cause some issues the first time you do it. And so it will shorten the longevity and the lifespan and cause sulfation on the plates and other things. So if you look at doing that with a lithium battery, the lithium iron phosphate that we make, let's just say you were to discharge it completely every single day down to empty and bring it all the way back up to a full status, 100% full. And you did that every single day for the next 10 years. That's about 3,650 cycles. And even after that point, you'd still have 75, maybe 80% of its original capacity. This is like a 15+ year battery, guys. This chemistry is meant to last that long. One of the reasons why we give a 10-year warranty is it's supposed to last like that. So longevity, cycle life, really, really good in lithium iron phosphate. Thermal safety. Higher temperature stability makes it easier to implement safety measures and prevent thermal runaway. Each of our cells internally, and there is 120 in each battery of these small little cells, is steel encased and is pretty stable. It's one of the most stable chemistries out there, the lithium iron phosphate, when you're talking about lithium batteries. So the Panasonic, well, not Panasonic, what was it? The Samsung phones, I think, blowing up in people's pockets gave lithium a bad rap, and everybody's worried that you get thermal runaway, some explosions. That just doesn't happen with the lithium iron phosphate chemistry. It would take probably around 550 degrees for a single cell to blow its glass cap, and at that point, it would cinder like a cigarette. It's not going to blow up and explode. So very thermally safe. All right, so what causes speaking of that, what causes some of these lithium iron phosphates to fail or cause problems? If you look at over voltage, let's say in a 12-volt battery, if you throw 14.7 volts or more at a higher voltage, it can cause a battery to fail in lithium. Under voltage, you can cause copper plating and a couple other things when you get it too low. If you actually discharge a lithium battery all the way down to empty, to where it is completely empty, it becomes pretty useless. So there needs to be protections in there. Lithium plating results at rapid charging at a real low temperature or on some kind of uncontrolled charging current. So you don't want to charge them too fast, even though you can charge much faster with the lithium batteries. So cell manufacturing defects. There's a lot of different cell manufacturers out there, and if they are bad cells, different variations in cells, they can cause internal shorts and some strange reactions, and of course degrading capacity. So you have to watch for that when you're talking about lithium iron phosphate. There's also, which is very common, prismatic cells out there, and they don't seem to cycle as long. They're not as thermally stable. They're in those little blocky pouches, and it seems like a lot of manufacturers, because it's cheaper to do that, seem to use those. And they're not rated as high as the steel encased cylindrical cells that we use. All right, so we just kind of went over some of that cell quality. Cells are made all over the place in Asia, and there's various different levels. So we work with a very specific manufacturer that we help actually work with the chemistry to to make sure that they do it right and provide the right kind of cells that are completely balanced and stable. Preventing battery failure. So how do you prevent all this stuff? How do you prevent having a problem with the batteries? One of the main things is, of course, the cell quality, like we talked about, and also a good battery management system. That's the guard at the gate, you guys. If you're looking at an over voltage, under voltage, anything that can go wrong, the battery management system should be able to take care of that and protect your investment. Yeah, so it's definitely necessary for safe operation of this entire pack. And you can see our GC2 battery down there. It's a little different kind of offset terminals on that one. So the BMS is going to monitor the cell voltages, the currents, temperatures, and it's going to make sure that it's in the safe range so you don't have any kind of issues. All right, so we went over a little bit about why lithium is better. And here's kind of a graphic representation of that. And there is a discharge curve for the lead acid on the bottom there. If you apply a voltage on those red lines, it has a tendency to drop pretty rapidly and in a declining curve. Whereas on the top there, varying different discharge rates, 10, 30, 50 amps at a time, you can see that that voltage curve is really pretty flat until you get down to the end there and it drops off. In a real world scenario, imagine your drill in your garage. Let's say you're using it and it gives you out full power until it's almost completely dead, and then bang, it cuts off because it reaches its threshold. Well, it's the same kind of performance that you're going to get out of a lithium iron phosphate battery like this. Really stable, really flat discharge curve, a lot better performance, and a lot of other advantages. So let's see here. Oh, and by the way, you can see how you pretty much always get 100 amps out of our battery. If you look at the end of that discharge curve, whereas the more amperage you pull out of a lead acid, the less you actually get. And that's in general called the puker effect. And it refers to kind of the shrink rate of your battery. The more rapidly you discharge the batteries, the more their effective size shrinks. For example, let's say you got like a 200 amp hour battery and you discharge it over 20 hours, that's where that rate comes from. But if you do it in an hour, you're probably going to get close to like 95 amps or something like that. That's kind of the puker effect in real world usage. A little confusing. If you want some fun reading, read on the puker effect. All right, so continuous discharge rate. Each one of our batteries in the 100 amp, let's go with the 24 volt actually, in the 50 amp, has a discharge rate of 60 amps continuously. And it's got the surge value of double than that. You've got the cranking value, which we didn't really make these as cranking batteries. Some people use them as such, but we don't really recommend it. This isn't really an engine starting or cold cranking battery. This is a true deep cycle, and it's meant for auxiliary loads. So you want to keep it to that. We are developing something that is going to be in the LTO chemistry, lithium titanate oxide, it lends itself much better to cold cranking applications. So that will be coming out sometime, hopefully in the next months. Of course, cycle life, much better, much longer cell performance versus pack performance. And of course, the weight savings. If you look at 200 amp hours worth of lead acid, the usable capacity is 100 amp hours because of that 50% rate. Well, you get much more than that out of the 100 amp hour battery. You get all 100. So basically, the weight savings and the performance you get is much better with the lithium. One battery is equivalent to 2 lead acids at 200 amp hours. So generally speaking, if you're not using more than 50% of the battery capacity of your lead acid bank, you can use one of our, let's say 100 amp hour batteries and have the same capacity. All right, just went over that 5 times faster. You can charge at a 0.5 C rate. Most lead acid batteries is only about a 0.2 C rate, and that is equivalent to, let's say, 0.2. If you take 100 amp hours, 0.2 of that is 20%. So 20 amps per 100 amp hour battery. If you're looking at lead acid, it's a 0.5 C rate with lithium. So you take your overall battery capacity in lithium let's say it's 500 amps, cut it in half, your max charge rate is 250 amps. That's a lot of power that you can put into the battery. Therefore, you can charge it a lot faster. You know, the resistance in lead acid is pretty high, and in lithium, it's very low. There's virtually no resistance in a lithium battery, so much quicker charge time. 50% battery capacity, we went over that for the charge rate, and then the stages. So lithium's voltage, it lends itself pretty well to existing charging systems as well. If you look at, let's say, a 12-volt battery, the requirement is 14.2 to 14.6. Of course, double that for a 24-volt system, like most of the Amel Yachts are. And if you set it in between there, it's going to charge properly. Given enough time, you're going to bring it up to full. So a lot of times you'll see a 3-stage charging method. Bulk absorption and float, very common out there. You set it to 14.4 to 14.6 times 2 again for a 24-volt system. And that is the bulk or boost mode. The absorption stage, the same as the bulk, and the float, you can drop it down to 13.6 times 2 for that 24-volt again. But the CC and CV settings are also highly compatible when you're talking about lithium. And that means, as you guys probably know, constant current, constant voltage. Throw 50 amps at a battery and leave it at that voltage setting until it's full. And a lot of times that float voltage won't even be there. Really, that's all you need to charge lithium, a constant current and constant voltage. So something like a Mastervolt or a Magnum, I think they can be set to that pretty easily. So highly compatible. All right, temperature, that's a big one that everybody wants to know about. You hear about lead acid batteries not performing well in temperatures or some kind of issue. But most batteries lose a lot of capacity when they're cold. And the same is true with lithium, but it's not nearly as drastic. So it actually performs quite a bit better in cold temperatures. And hopefully we'll have a good paper for you guys to read on that sometime soon. The thermal protection in our batteries, if you look at let's say the charging, the storage, and the usability in regards to temperature, you can store our batteries down to -10, -15 degrees without any kind of problems. They will cut themselves off on the high end at about 135 to 140 degrees internally in the BMS. That's a parameter in there for thermal protection. If you're looking at usability, down to -4, you can still use the batteries and get really great performance. After that, we say, yeah, you should probably stop it at about -4. It's not really good to use it at that temperature anymore. The batteries will shut themselves off at about 135 degrees Fahrenheit to 140. That's a good place to cut them off. Now, when you're charging, we have kind of a special thing that happens in the BMS. If you are under 25 degrees Fahrenheit, and that is the internal cell temperature, it's going to not allow a charge to come through. Now, you can still use the battery at that time. You can still pull power out of it, even down to -4 degrees, but it will not take a charge unless you get it back up to 32 degrees Fahrenheit at that point. So that's a really good thing. You don't want the batteries to get damaged because you're charging in too cold of temperatures, and our battery will not allow you to do that. So, really good feature. And those are pretty much the basics of lithium iron phosphate batteries in general. I'm sure that you guys are going to have a bunch of questions, like usual, how to integrate them into the systems. But that covers all the basics for you.
Let me interrupt. Before we get to the specific questions, I'd like to ask both Brian and Justin if they have anything to add to what you just saw in the presentation. And that start with Justin. Justin, is there anything that you'd like to add to the presentation?
No, not really. I think he's covered all the bases. That's the basic stuff of what we need to see for charging and for temperature. Obviously, on a boat, obviously there's different conditions.
Could you speak up a little bit, Justin?
I said, obviously, on a boat, there's different applications that would be in other applications off grid. But obviously what Jesse said is the basics of the lithium iron phosphate.
Okay.
Can you hear me okay?
I didn't hear you, but maybe other people did.
Let me try and turn my volume up.
I think we heard what he was saying. Yeah. Mm-hmm.
Oh, okay. All right. Well,
Mm-hmm.
let's, can I flip over to Brian? Brian, do you have anything to add?
Yeah, can you guys hear me okay?
Yeah,
Beautifully.
Okay, great. Thanks for inviting me today. So yeah, there's two things that I thought of. Number one, a lot of people don't realize the additional charging efficiency with the lithium batteries. So when we switched from lead acid to lithium, it was almost the same as adding another solar panel for us. And we saw almost a 30% increase in actual power absorbed by the batteries. We, when we installed the latest ones, we gave the other ones to a friend, and they also realized the same thing. So they're actually getting more power into the bank now, which, it's not, like I said, it's lower resistance. So that energy is actually going into charging the battery rather than creating heat and bubbling and all that, which is pretty cool. And then the other thing is I have run them down to 0, or I guess wherever the BMS cuts off. I think it's 10.5 volts. Is that correct, Jesse? Yeah.
That's correct. 10.
If you do that, you have to make sure that you have a battery charger that will apply voltage with no battery being seen on the end. Because I have talked to boats that bring them all the way down. They become a dark ship. They turn on their generator and the battery charger, and nothing happens. And they actually need to apply a stimulus voltage to the system to get them to the BMS to turn back on and start charging. We have the Victron chargers. We have 2 of them, and both of them seem to work just fine. I don't know if they have they can act as a power supply or something like that, but I guess that is something to be aware of.
Let me add to that, Brian. Yeah, you're absolutely right. The thing about a BMS cutting off when it is empty, it's a really good thing to protect the batteries, but that can cause issues with charging devices that need to see a set voltage in order to throw the amperage in. So a good example of that would be, let's say, a solar charge controller. Typically, those need to see somewhere in the neighborhood of, if you're looking at a 12-volt bank, like 9 volts or something like that. When the BMS shuts down the battery, you're no longer seeing 10.5 volts. If you were to take a voltmeter and put it on the pins, you're going to see anywhere from 0 to 5 volts typically. And the charge controller is just going to show its top end voltage and not put anything in there. It's just going to say, oh, there's not a battery here. So like the Victron stuff, which is great, it doesn't need to see an actual voltage range. It'll just start throwing power in there. Another one would be like jumper cables from a battery that has more voltage into it, and it will wake it up out of the low voltage disconnect state and bring it back online. Alternators typically do that as well. They don't need to see a certain voltage to kick the power in. So yeah, that's a really good one to address.
Oh, so the quick fix is if you bring it down to 0, start the engine, use the alternator. Is that right?
Typically, yeah. That unless there's some kind of device in between that needs to see a certain voltage. But yeah, in general, alternators will kick them back into that 10.5 volt range, wake them up, basically.
Yeah.
And you can throw a charge back in.
Yeah. Anything to add, Justin? Or
I think that's very good points. And obviously, obviously when they go that low, then you've got to wake them up somehow. Obviously, an MPPT will do it, obviously, in some applications.
Okay. I'm going to turn it back to Tilo to handle the questions, but I want to say one thing before I do that. Normally, we limit this to an hour. We have quite a few people, and I think there's probably quite a few questions. So we're not going to be cutting off at exactly an hour as we have before. So we'll let this one run a little bit. And Tilo said he's here as long as you're asking questions. I think that's what you said, right, Tilo?
That's right. Yeah, so that's good. Justin, did you have anything in general to add from the perspective of transporter energy?
Transport energy obviously is a European division, so obviously we handle orders over the European and UK territory. Obviously we fit out a lot of boats with the lithium kit now with the lithium power system. And people report back saying that
Justin, your volume level is pretty low, so if you can just speak up or come closer to the mic.
See if I can turn that up.
Because you're not registering enough to trip the speaker view over to your presentation.
Okay. Can you hear me now?
This is much better.
That's better.
Yes, I mean, obviously all the boats we fitted out over Europe over the period of time since we've been distributing the batteries, everyone comes back and says, you know, it's an amazing difference compared to lead. And I have people phoning me up saying that obviously they've had many problems with lead, and you know the lithium is the answer for them to stay off grid. And obviously the maintenance factor is a lot less, and they'll be able to leave their boats for longer periods of time without maintaining the batteries as they would with lead.
Okay, great. So so that is good, and so I see that Billy added a comment in here that some batteries have buses to talk with charging devices, so they all work together. How does the Battleborn system work, given that there is no bus? And he mentions he has all master volt and that their batteries are master bused with the alternator and chargers, for example.
Jesse, do you want to come on?
I'll address that. Yeah, so some batteries out there have external BMSs or like a VCAN network that can communicate and provide external information. We decided to do that internally, basically, without having VCAN communication or anything of the sort. We thought for this market, it would be better went to a drop-in application. So there's not a lot of, well, there's no way to communicate with the batteries internally, but the BMSs work in conjunction with each other to make sure that everything is taken care of. So yeah, no internal communication available right now. If you need to get data internally on the battery, you know, it can be best served as like a Victron BMS, BMV, I should say, BMV 712s. You can get some of the information in regards to current, voltage, and can be transmitted to some of those devices. But yeah, for right now, no communication into the batteries. Might be in the future.
Okay, that's good. And JB asked, what kind of hardware changes do you have to consider? Of course, keep in mind that a lot of the Amels, you know, are 30, 40 years old. And so what do these people need to think about if they're going to upgrade? Actually, I think in this sense, I don't know, Jesse or Brian could probably answer that very well, because Brian has been through it.
And Tilo,
Yeah.
Bring up the slide number 2 while they're talking, or I can bring it up.
I can bring it up. I've got it. So
this is a slide of bundles for, slide number 2. The one on the left is Battleborn, and the one on the right is Transporter. Now, the batteries, remember, are Dragonfly batteries under 2 different brands. Battleborn is Dragonfly's own brand, and Transporter is the European distributor for Dragonfly batteries. What you see here is I, on behalf of all Amel owners, got together with both companies, Battleborn and Transporter, and came up with some packages, some bundles of batteries and Victron equipment to complement it. These are assortments that the engineers at Dragonfly helped put together. It's what you need. And I think answers the question that's on the table right now. If you look at the left side, which is Battleborn, you can see that you have a choice of 400 amp hours, 500 amp hours, and 600 amp hours. The basic three sets. But if you look at the 600 amp hour, you can see you got a 500 watt inverter charger. In other words, you're going to have AC current up to 500 watts with that system. It's a pretty awesome system. That particular system would take 12 100 amp hour batteries, or 24 volt 50 amp hour batteries. Now, Jesse and I have talked about this. Justin and I have talked about it. I really recommend that everyone on an Amel think about using 24 volt batteries rather than taking two 12 volt batteries and putting them in series. You'll have a much more even charge rate on all of the battery bank if you do that. And on the right is a bundle from Transporter Energy that includes, for instance, 8 100 amp batteries. Transporter can also offer the 24 volt batteries, I think, and I think that is correct.
Can I come in there? We are still waiting for the 24 volt batteries to finish.
You're still waiting? Okay.
Still waiting to finish all the
Okay.
testing. So
well, probably around the corner. But these are bundles to help people begin to think about what they want to do. Justin is prepared and ready to do a custom bundle for any Amel owner, and so is Battleborn. So I'm going to jump back out, and first, Justin, you want to jump in and add anything to what I said, and then we'll let Jesse come back and add anything to what I said.
Okay. All I was going to say is at the moment we only have the 100 amp available. That's the only one that's finished all the Intertech testing that we're allowed to in European areas. So that's the only one we have available at the moment. We hope the rest of the testing on the other batteries will be completed in the next couple of months, and then we will be able to offer more of the range. Okay.
Okay, Jesse, any additional comments on that?
Yeah, you know, the 100 amp hour 12 volts and the 24 volt 50 amp hour both work really great in both scenarios. You know, the 24 volt in parallel, you know, you get a little higher discharge rate if you go with that effect. But either way, you know, you're going to get the watt hours, you're going to get the performance. So whichever you choose is really up to you. But the BMS is going to control or protect, I should say, in any instance. So with series connected banks and even parallel, we have what's called a passive top-end balancing in the BMS, meaning as soon as you get it over, let's say in a 12 volt battery over 14 volts or so, it's going to bleed off current into or amps into any of the cells that are not as full as the others. So that top-end balancing is a really great thing for series connected batteries and these kind of battery banks in general. So it becomes more important to fully charge with a good absorption cycle when you're in series rather than parallel to keep those batteries balanced. So that's about the only thing I'd add to that with the 12 and 24.
And this is an interesting point, and one that I've been dealing with some companies locally and here and in South Africa, ironically, that are doing BMSs. And as I understand, what you're doing is you're doing cell by cell internal balancing, which according to the experts that I have here in Switzerland, they're saying that's actually the gold standard, to have internal balancing, because that handles it within the cell and you don't have to worry about communication across the different banks of batteries, because they should then each interact as a complete unit and be independent in that way, but still balance across the bank. Is that correct?
I'd say, yeah, that sounds pretty accurate. I mean, individually or within a series or parallel connection, you're going to get that same top balancing effect. And I think that's the right way to do it if you're talking about a drop-in replacement with an internal BMS. So yeah, I would agree with that.
Now, one question that came up from Brent and Billy was that you've got a series parallel configuration, whether you've got 12 volt or 24 volts, and one of those batteries, one of the BMSs shuts down the system. And so you've got one battery that goes out. How does the rest of the system adapt to that?
Good question.
Yeah, if you look at, let's say, a 300 amp hour bank in series and parallel with 12 volt batteries, let's just say one of those batteries goes out, it cuts the amperage basically and keeps the same voltage. So two of those batteries would basically go offline because it wouldn't be 24 volts anymore. And you'd have 200 amp hours at, let's say, 24 volts. So you have kind of a protection in there where the whole bank is not going to shut down on you. You're going to have just lessened capacity until you can take care of that battery that shut down for some reason and cut off the other in series. So yeah, there's a measure for that.
Mm-hmm. Okay. One of the questions that comes up a couple of times here that I'm seeing is, what about the cost comparison? Now, I know that Ken on Sailing Aquarius did an analysis of that, and this was about a year ago or so, and he was saying, given the fact that for a full-time cruising sailboat, you're going to go through a bank of lead acid batteries in probably 3 years if you're lucky. What is the, and he came to the conclusion that if you're going to own your boat or for more than 3 years, you're better off going with lithium batteries than lead acid. Has this equation gotten even better? And do we foresee that prices will continue to see a strong price advantage here?
I think that the cost per cycle, if you look at the longevity and the lifespan of lithium, is much cheaper than lead acid. You're getting 5 times or more the longevity if you look at every 3 years, 3, 6, 9. I mean, five battery banks as opposed to one battery bank for that 15-year time span, and probably even longer. So yeah, I'd say it averages out to a better cost. Plus, you get better performance, lighter weight. Who doesn't want a lighter weight in the boat? Mm-hmm. So there's a ton of advantages when you're talking about that.
And
yeah, that's
the environmental impact as well of those batteries. Obviously, the lead acid, obviously they're being dumped everywhere. So obviously the impact over the environment. Obviously, we work very closely with the environment for the different projects we do, and we care obviously of what happens in the sea now. So,
that's a good point, Justin. I don't think a lot of people realize how toxic lead, those chunks of lead, those lead acid batteries are. One lead acid battery can contaminate acres of municipal waste. We're pretty good in this country and others about recycling the proper way with our lead acid, but if one gets stray, it can cause a lot of damage. One gets stray with the lithium iron phosphate, what's the damage to the environment? 0. This is a non-toxic chemistry. So this is not only better in performance, on longevity, in weight, in cycle life, but also it's green. It's an environmental impact. I mean, it's going to change. If everybody was using lithium, you would have much better environmental effects. So yeah, that's a good point, Justin.
So you bring up 2 interesting points here, and one is charge efficiency, the other is weight. So what I'd like to do is kick this over to Brian, and because one of the questions specifically is, given the difference in weight between lithium and lead acid, Brian, how have you seen the trim of Delos affected by that?
Okay, I want to add one thing before I forget about it is, as far as the cost, something that people don't realize is even though we added more electrical load we added an electric cooktop, an electric oven. We're now running our washing machine off the inverter and everything. We still saw our generator runtime go down by about 25%. And that's because they just suck in the power, and they will just charge at full power, and then they shut off. And so I was really happy to see that, because that means less maintenance. I've extended my range, less fuel, if you want to add that to the equation. Now I forgot what you just asked me, sorry.
About the trim and the weight. Yeah.
Yeah, we list even more to port than we did before. Because yeah, I mean, the old lead acid batteries were about 25 kilos each, 50 pounds. These are 13 kilos each, so they're about half the actual physical weight. So yeah, it's become more noticeable.
Mm-hmm. Are you able to run your water maker on the inverter?
No, mostly because I don't think the inverter has enough oomph to it's a big AC motor, and the cold the lock rotor current on that is pretty huge. I think it's somewhere in the neighborhood of 800 amps, and it would just, I think I could probably get it to work with a soft start, but the water maker's so big anyway, we just run it a couple hours here and there a week and call it a day. Yeah.
Okay. That's great. Did you need to install a new alternator because of the amp load on those?
We didn't do anything with the alternator. The only thing we did was install the alternator protection device in the case where if something went terribly wrong, we didn't want to overvoltage the system. So the alternator is still the internally regulated 50 amp, 24 volts that came with the boat. It's not ideal because the charging profile is for lead acid batteries. So because these batteries operate as at a higher voltage, we never get an ideal charge when we're motoring. It takes a long, long time because the current continues to degrade. And I mean, we could fix that with an external regulator, but we rely mostly on solar, wind, and when we need to, the generator. And so the alternator for us is like a fourth fallback power source, I guess.
Okay, good. One question, Jesse, I guess for you about the warranty terms. You say it's a 10-year warranty, and is that prorated over time, or is that direct replacement?
Yeah, it's an 8-year full replacement, if you have any kind of manufacturing defects. And the last 2 years is the prorate. So, by that time, we're going to have a battery that is, I'm positive, much, much better. And you're going to want a really good discount on that.
Okay. Okay, and then, so Sailing Rascal had asked, can you talk about optimal charge level? Because he's heard, and I've also heard this, that it's better to charge lithium ion to 80% versus 100%.
Absolutely, yeah, that's a big one out there that everybody thinks that you have to keep it in a certain range. If you're looking at like a Tesla NMC battery or something like that, they want you to keep it in a specific range for the optimal health. These batteries, we wanted you to be able to kind of use them and abuse them without having to keep it only at 20. Don't go below 20%. Don't bring it all the way up to 100%. Well, you get the same longevity if you, again, like I was saying earlier, run it down to empty and then all the way back up to full every time you use it. You're not going to get such a drastic effect on longevity like some of these other manufacturers are getting if you only or you go below 20% of the capacity. It's a big thing with prismatic cell batteries. If you go below 20%, then that cycle life that they tell you you're going to get is going to diminish significantly. Because we use the higher quality cell and better components, it's going to last you at least 10 years. That's why the warranty is there, even if you discharge them a lot. I mean, talking about 100% full, a lot of times people are thinking about storage with that. We always recommend, hey, bring them to a full state of charge let them sit, make sure there's nothing coming in or going out, and you should be able to come back 6 months later and still have, around a 70% full battery. So not a big concern. If you're looking at the biggest effect on longevity on this battery, in our testing, it's been charge rate. We recommend that 0.5C charge rate. Let's say 50 amps per every 100 amp hours of battery bank. Now, if you go 60, 80, 100, you're going to diminish the overall lifespan of that battery. We don't limit that, the charge rate in our BMS, and there's a pretty good reason. If you're 1,000 miles from shore and there's a hurricane coming or something, and you need to charge your batteries fast, we're not going to stop you. You're not going to you're not going to damage the batteries even up to close to 100 amps worth of charge per battery. Past that it gets a little excessive, but yeah, there's definitely no great loss when you're talking about keeping it within a certain range. Charge it all the way to full, bring it all the way down to empty, as long as you know how to get it out of that low voltage disconnect, and you're going to be fine.
Okay. Now, one thing that those of us with things like iPhones have seen, if you leave the iPhone on charge all the time, then it's going to cook the battery eventually. And of course, people also have that question about having their, if they've got their boat docked for the season, or they leave it all winter, and onshore power on the charger, presuming, let's just say, if they've got the Victron charger, will this still maintain it at a level that won't cause any significant degradation? Or if so, what degradation might one expect?
Yeah, great question. Yeah, and that comes up quite often also. The 13.6, which is typical in a 12 volt system, or the 27.2 for float stage in a 24 volt system, completely acceptable for long-term plug-ins. Some people want to leave them plugged in all winter or for quite some time. Yeah, it's totally acceptable and fine, not going to cause any damage. If you were to have a higher float set point, let's just say you had it at 14 volts or over, which of course is 28 volts for a 24 volt system. That if you were to apply a higher voltage, I really don't think it's going to cause damage, but it's not the best thing for the internal BMS. You have a float voltage of like 14.4 or 28.8. After about a month, I'd say, why don't you just disconnect that thing? There's no reason to have that connected with that high of a float voltage. But 13.6 or 27.2, around that range, completely acceptable.
Mm-hmm. But of course, most lithium capable chargers will give you the ability to set your float voltage, right?
Correct. Yeah, very common. You can adjust those appropriately. And really, if you look at the typical settings that are not adjustable, an AGM setting is pretty darn close to that. So a lot of times that is all you'll need, even on those old chargers that don't have the ability to change it.
Okay. So, and somebody was asking about if they have a 175 amp alternator, but according to your calculation, then if they've got, anything more than a 150 amp hour, or no, a 300 amp hour capacity, that should be just fine, right?
Yeah, 175 amp alternator with a 300 amp hour bank, that's pretty close to the 0.5C rate. It's a little over, and we see people going that rate without any kind of problems. I mean, are you going to get 20 years out of the battery at that point, or 19? I mean, it's pretty insignificant. And if you want to regulate that current, of course you'll see DC to DC chargers out there directly from the starter banks, or something like a Balmar that's going to regulate it down a little bit, that can control it. So if you're really concerned about going past the 0.5C rate, the 50 amps per 100, then I would say look into some of those devices for the best longevity.
Mm-hmm. Okay. And then the other question is, storing a battery in a no-load situation, can you just disconnect them and leave them stored at 100% over a season?
Yes, absolutely. Maybe 2 or 3% capacity loss, not overall capacity, but per month. Again, you should be able to come back, putting a battery in full and then storing it, coming back in 6 months and still have around 70% capacity. Unless you have extreme temperatures, like something really cold or really warm, it's going to have a more significant effect on the self-discharge rate.
Okay, but you won't come back to a dead battery, or it won't cause any harm to it.
Pretty unlikely. You can store these things up to a year, we say, without throwing a charge into them. So it's pretty common.
Okay, good. And somebody was asking about the Victron color controller and if that offers any special advantage.
Victron products are great. That's a great company. They started in the marine industry originally, been around for a long time. The color control, GX, Venus, Serbo, all those GX devices are absolutely compatible with our batteries. I mean, they're monitoring devices that basically are a hub of information for all those Victron components. So yeah, the color control is nice because if there is any kind of error or fault, it'll get more detailed in what that fault means with an error code that you can look up. Whereas something like a BMV 712 battery monitor isn't going to give you an error code that you can really look into like you can a color control GX.
Okay. Brian, what kind of a controller do you have on yours?
We've just got the BMV 712, but I do have the Bluetooth network enabled with a, I can't remember what it's called, the Victron product that broadcasts battery voltage, temperature directly from the bank itself over the Bluetooth network, which all the charge controllers and the BMV 712 and everything kind of shares the information, which I think is pretty
smart
cool.
network, right?
Yeah, the smart network, that's what it is. Yep.
Mm-hmm. And what kind of information are you getting off of that?
The only thing I really care about is voltage and how many amp hours I've used. You know, we use the hell out of these batteries. I mean, we run the stove all the time. That's 2 kilowatts. We're running the washing machine, even in the heat cycle, that's 2200 watts. They hold their voltage high. I think I haven't run the generator in like 5 days now, and we're down about 240 amp hours out of our 400 amp hour bank. The voltage is still sitting right around 26 volts for us. And I mean, maybe I'll run it in another couple days, the generator, top them off or something like that. But yeah, I mean, it's pretty straightforward, really. I pay attention to the same stuff I did on the old batteries. It's like now I just care less, I guess.
We call that losing your battery anxiety in the industry.
Yeah.
With lead acid, you say battery anxiety, and everybody gets it. They're like, oh yeah, I always got to worry about those batteries. Well, you do that a heck of a lot less when you have a good lithium system set up.
I mean, we even stopped, we used to really turn the inverter off, and now, I mean, we leave the computers on all the time. I leave the inverter on because we have a baby monitor that needs to charge overnight. So it's actually really been a game changer for us.
Great.
Mm-hmm. Okay. Now, a question from Brent is, do you have to periodically rebalance the batteries within the overall bank, or does the system handle that?
Yeah, that top end balancing usually takes care of it. If you're regularly bringing your battery bank to a full and complete charge, it should balance. If you're worried about it, or if you have any concerns, you can always kind of take them out individually and bring them to a full and complete charge. Once a year or what have you, with a separate charger, and address that separately. But yeah, the top end balancing that kicks in is going to keep those batteries equalized, or I should say balanced. Yeah, there's a measure for that.
Okay. And one question from Brent is, given the huge load capacity of the lithium ions, do you still run the generator if you're going to be using your bow thruster, or do you just rely on the batteries to work that through?
Yeah, we just use the batteries. I mean, it's a huge draw, right? But what is that engine? I can't remember how much the motor is in wattage, but I mean, we've never had any problems with it. The only time we'll have a problem is if we're maxing out the inverter, you know, and that's pulling a bunch of current, and then we use the bow thruster at the same time, and I have the satellite running, but you know, like that's not a very common scenario, I don't think.
Mm-hmm. Yeah, and but that has been an issue that's been mentioned in the forum relatively quite recently, is that people have cooked their lead acid battery banks by not running the generator in that. And it's been pointed out that, okay, well, you're running your alternator, but you're running it idle usually, which doesn't give you any boost.
Yeah, well, if you think about the parallel configuration we have, if each battery is capable of putting out, what's the C rating? Is it 100 amps or something like that? And then, you know, you've got 4 of these in parallel. That's 400 amps at 24 volts. That's an incredible amount of power. That's, what is that, 8 kilowatts or something like that? Like that's a lot. And then there's the 30-second time where you can exceed that. So I don't know. I've never had an issue.
Mm-hmm. Yeah, that's Ken says, yeah, 400 amps for the bow thruster is what it takes. So that's a good thing. Now, one question that Wolfgang had was, it seems to him the conclusion is that if he's looking at upgrading and he's got an either or decision process to make, does he go with solar first or lithium ion? And it sounds to him that lithium ion is the first step and solar is the complement to that.
Yes, I definitely agree with that.
Mm-hmm. Because I think I've heard.
If you look at what solar did. Sorry, go ahead, Tim.
I was just thinking, it seems that what a lot of people have been saying is the other way around. Put in the solar, and then after that we'll do the lithium ion upgrade.
Yeah. Either way, you can start with solar if you want to, but if you look at what solar does, solar charges batteries. If you have the right battery bank, you know, and you have it dialed in first, well, you'll know how much solar to put on. Otherwise, you're stuck going, okay, I think I'm going to put in 400 amps worth of batteries. You know, how do you size your system to what you expect to have or what you have now? So I lean a little bit more towards doing the batteries first. I think it works out, but you can do it both ways, really.
I supply lots of boats, but obviously they're changing the batteries over, but they haven't got solar yet. So that's their next step. That's what I see a lot with people. Or they've got older solar, but they want to upgrade. It's been on the boat a long time, and they want to change the system because obviously they've got new batteries now. They want to upgrade it.
Mm-hmm. I think, Brian, you talked about that in your analysis of your follow-up on the install, and you talked about how amazing it was that the reduction, and you mentioned it here, but just the fact that it charges pretty much at 100% charge rate up until 98% or something, and so you get your batteries charged really quickly. Isn't that right?
Yeah, yes. I mean, we have 3 different battery chargers, a 70 amp, an 80 amp, and a 100 amp. So there's 250 amps of charging capacity. I usually only run 1 or 2 chargers and keep the third as like a fallback just in case the other ones fail. But I mean, we can go from, you know, even charging that 130 amps. If we bring the bank down real low, we can fill up the whole bank in like between 2 and 3 hours from completely flat. And I remember with the old batteries, I used to have to run sometimes 2 hours in the morning and then 2 hours in the afternoon. And that would be the batteries at 50% or 60% capacity. So yeah, I mean, they do charge incredibly fast.
Mm-hmm. So that really speaks to the advantage of even without solar or anything else, just saving your generator time by going to lithium.
Yeah,
And absorption.
Big fan of solar though. We have a lot of solar on the boat now. We found another way to stick another 700 watts up on the Dodger up on the Bimini. So that's pretty cool. We're getting like almost 6 kilowatt hours of solar power now, which is insane.
You know, in regards to the whole charging rate, if you think about the absorption stage that most chargers get into, with a lead acid, typically you get it to about 80% full, then it switches from bulk to absorption. Well, it can take up to 5 times as long to get it through that absorption cycle as it did to go through the bulk cycle. I mean, if you have an hour in bulk and you get your batteries up to 80% full, I mean, you're looking at another couple hours to bring it up to 100% full because of that internal resistance. With lithium, as Brian was mentioning, I mean, you get them up to like 95, 98% full, and then it goes into absorption, and that's a really short time frame before it goes into, you know, a maintenance kind of flow charge. So it is a great advantage to have a short absorption time. You know, if you look at, well, it's a different analogy, but yeah, the point is it does definitely charge a lot quicker.
We work very closely with the ambulance service now. We actually build ambulances with the batteries from scratch. And they've noticed with the old lead acid batteries and the AGM battery put on the ambulance before, obviously they were charging a lot longer time every night. With the lithium on the ambulances, they're not actually charging them, obviously, off the engine or off the solar, but they're not having the same charge rate as what they were before. It means that obviously they can operate for a lot longer time without being charged.
Yeah, that is an interesting thing. I was also working with a company in South Africa that was doing battery management systems for forklifts, industrial forklifts, and just in 6 months between the time we started working for them and they were looking at lead acid battery management systems, and the price of lithium ion just dropped to a point where all of a sudden it was a complete game changer. They were able to change out lead acids in these industrial forklifts, and the companies that were using them just said that was amazing, because then they could run 24 hours a day pretty much and charge up their systems over the breaks, whereas before they'd have to have one forklift sitting out for a shift in order to accommodate that.
That's exactly the same with the ambulances. They have a spare ambulance just in case the other ambulance isn't charged. So, you know, obviously, and they're looking at trying to reduce the weight all the time, and now they're building lighter ambulances because of the result of the lighter batteries. Not having so much load. They're obviously using a lot less fuel, and so it goes on.
Yeah, and so Luna was asking Brian if you can run the hot water heater off of the batteries.
Yes. I wouldn't. I mean, I don't though, because I don't know. We guess we don't use hot water that often. But I mean, our hot water heater is 1800 watts, I think. So technically, it would work. The one thing we do use all the time is a hot water kettle. That's about 2000 watts, and it's just so much more convenient to pop that on in the morning, have boiling water, and 30 seconds later, as opposed to having to use propane or gas or something, or a kettle. But I don't see any reason why the hot water heater wouldn't work, except at some point you have to find a way to put that power back into the batteries, right?
Yeah. So Brian, how did you change the wiring on your main AC panels to accommodate this the new reality of running things off the inverter?
I actually just created a small separate bus, and I tapped into, there's quite a clever system where Amel will take power from either shore power or from the generator or from the inverter. And what I ended up doing is tapping into the same side that, you know, some of the outlets were on for some things like the washing machine and stuff like that, so that, you know, it runs pretty seamlessly. And with the 3 kilowatt inverter we have, it automatically kicks on should, you know, the generator, you turn the generator off or something like that. So we don't really think too much about, you know, okay, generator, we just leave the inverter on all the time, and it handles it.
Okay, so you actually only have the 3 kilowatt inverter. I was surprised. I would have thought you went with the 5.
No, I mean it's plenty for us, really. The only times we get in trouble is if we're doing laundry and trying to cook a big meal at the same time, something like that, in which case we would probably just turn the generator on for that, that instance.
Okay. And what's your amp hour capacity for your battery bank?
We have 400 amp hours at 24 volts. So eight batteries, which is about all we can fit in our battery storage compartment on the Amel from RM. I think if I move the starter battery somewhere, I might be able to squeeze another 2 batteries in there. But I mean, that amount of capacity, even for us, and I think we're pretty large electrical consumers on this boat, it's been pretty fine. Yeah.
Mm-hmm. And what about the heat buildup in the battery compartment? Do you find that that's lower with the lithium ion, or do you need to adapt that to get more ventilation in there?
I think it's a lot lower because the batteries have less resistance, and so, I mean, sometimes when I will, when I'm checking them out, I'll charge them at full power as much as I can shove into them and touch them, and I can't even feel a difference cranking in 150, 200 amps. Because if you think about it, with 4 banks in parallel, each one is getting 1/4 of that current, so you're charging it 30 or 40 amps per battery for us mainly, and so we're still under that 50 amp per battery deal.
Okay. Now, and are you using 24 volt cells or 12 volt cells?
We just have the 12 volt 100 amp hour batteries, and it's pretty much the exact configuration the boat came stock with. I was able to reuse the same cables, the same series bridging battery cables. They're the same size, so I just put them in, bolted them in. The only real change was configuring the battery chargers and the solar chargers and the wind charge controllers for the lithium voltage profile, which it was all relatively new stuff. So that was just a matter of going into the app and setting the voltages pretty much.
Okay. Did you have to run a larger cable to the battery, from the battery chargers to the battery bank?
No, I didn't, because we didn't actually increase the size of the battery chargers. They were the same current as before. And so, yeah, I just used what was there. The one thing I did have to increase was the battery cable to the inverter, because if I recall, the inverter there was 1,000 watts when I got the boat, and now we went to 3 kilowatts. So I just went with a giant cable and had to run that through, which is a real fun experience.
So I think there's a plug in the conduit that goes back into the engine compartment that you have to pop out, right?
I think I might have mentally blocked out that period of my life or something. Yes, I think you're right.
Okay, that's good. So yeah, so basically the wiring is the same except for the, if you increase your inverter, whether it's lithium ion or lead acid, you're going to have to bump up your cable capacity there. So I think that's good. And you didn't have to really reconfigure anything about ventilation for the battery compartment, any other things in that sense. So and the batteries are, and whether they're 24 volt or 12 volt, Jesse, I understand those are direct drop-in replacements, correct?
Yeah, and when we say drop-in, it's pretty much the same size as what you're taking out, unless you have something larger than around 100 amp hour battery, and the group size is around group 27 on the 24 volt and the 100 amp hour 12 volt.
Mm-hmm. Okay, so that's good. That was one of the questions. So basically, if you were to switch out from using standard 12 volt lead acid to go to 24 volt then you just would lose you'd have to rewire the cable runs to have them in parallel in that sense. Yeah.
Yeah, if you were to change over from, let's say, a 6-volt battery bank ran in series to a 12-volt battery bank ran in kind of a series and parallel configuration, you might need some extra jumper wires or something of the sort, but it's a pretty easy configuration change.
Okay.
Can
Now,
I-
Scott, yeah.
Can I jump in a minute? I just want to make sure, I'm not sure it's clear to everyone. Brian's Super Maramoo has a capacity for 8 Group 27 batteries, I think. And then later model Super Maramoos and all of the 54s have physical capacity for 12 Group 31s. So Brian filled his up, but there is a later model Super Maramoo that came standard with enough room for 12 Group 31s. Okay.
Okay. So yeah, and that's an interesting thing. You can really amp up the capacity there. Brian,
I just couldn't imagine needing that much power, though. Really, it's like insane.
I meant to follow that up with a question. If you had a later model Super Maramoo that had room for 12 Group 31 batteries, would you still have 8?
Depends on how much money I have, I suppose. I mean, sure, why not? I mean, everybody likes to have a lot of power. Do I think it's necessary? No. I mean, we've done just fine with the 8 batteries we have on board, and I think we're higher than average users as well. So.
Okay. Now, and Jesse, the Battleborn batteries have also a Group 31 option. Is that correct? You have a configuration for a Group 31 size?
It's more like if you're looking at the 12-volt 100 amp, there's 2 separate versions of that. One is the Group 27, let's say 12 3/4 by 7 wide by 9 tall. We also made a battery with the same voltage in what's called a GC2 footprint. And that mimics a lot of the 6-volt batteries out there. It's a little more narrow and taller for tighter compartments where you have more headroom, but not enough width. So that one is what we have. It's not a Group 31. And then we have that small 50 amp capacity 12 volts. So no Group 31. It's the Group 20. We call it a Group 27, but that footprint is really in between 27 and 31 in that rectangular shape.
Yeah.
Okay. One question about the lithium batteries, is there a requirement that you have to store them horizontally, or can they be put in any position?
You can hang them upside down from the ceiling and let them swing. No orientation necessary. You can and they're in that regard, orientation wise, they're so safe too that you can use them as a pillow. I mean, you don't have to worry about ventilation, off-gassing, terminal corrosion, any of that.
Okay. And basically the 24-volt batteries you're offering are in the exact same housing. It's just that instead of, you basically are hooking them up in different series of configurations, right? So it's a 50 amp
Correct.
instead of a 100 amp, right?
Correct. Yeah, the internal wiring is a little bit different. Externally, it looks the same, except for the posts are on one side of the battery instead of the left and the right. It's a good idea because you don't want to accidentally think you have a 12-volt battery when you have a 24. So we put it on one side of the battery.
Yeah, good idea.
Mm-hmm. Yeah, that's good. So I think, let me just check here. And so one question is that we're seeing technology move very quickly. What's the next step that we can expect to see? Are we at a pretty stable state with lithium ion technology? Are we just going to see price advantages increase on that? Or are we looking at some future evolution?
I think it's pretty clear to the world that lithium, once you start researching it, is in just about every way better than lead acid, except for, I guess, the upfront cost, even though it's cheaper per cycle. And I think it's going to continue to go down over a period of time where it becomes more popular even from now. In regards to new product development, I'd mentioned the LTO battery, like a starter battery for some applications. We're moving towards that, an internally heated battery, which will self-heat at a certain temperature range, which I think is a really good addition. Everybody wants a larger capacity battery as well. So we're working on sort of an 8D footprint, 255 amp hour battery that will be out soon. The technology is just going to increase and continue to improve. There might be some Bluetooth connectivity, but yeah, there's some technology on the horizon that's just going to keep moving with the times. So keep an eye out for those things.
Okay, so that's good. Does anybody have any other questions here? Oh yeah, this is one question that had come up. On the pricing sheet, it said delivered price, but that stipulates it's in the continental US. What is the availability in the Caribbean, and how does that affect lead times and delivery costs?
It's different everywhere. I mean, if you're in the continental, we'll deliver it to you at no shipping charge. If you're outside of the U.S. somewhere, it's almost like you got to give us your address, and we'll run a shipping quote for you, and let you know how much it'll be. Of course, you can take advantage of Justin being over in Europe and can see how much it would be from him and their transport range. So yeah, it's a conversation always. Give us an address, we'll let you know how much it is to ship, and the time on the water or in the air.
Yeah. So Justin, a question for you, because of course many people go to Saint-Martin or Martinique. Are those considered part of Europe, or how does that affect availability in that sense?
Well, certain islands, it depends where it is. Obviously, you've got the European continent, and certain islands, even in the UK, are obviously harder to ship to. And obviously on the European continent, obviously over land, it's a lot easier to do with them. But obviously when we go to islands and different stuff, then we have to use different shippers. And obviously the cost goes up. But on a standard shipping rate, we are looking at, for say, 8 batteries to Italy, we're looking about £50-something plus whatever the input charge is.
Okay, good to know. But I guess that's an interesting question, I guess, about Martinique. Is that considered, whose territory is that? Because it's geographically it's Caribbean, but politically and territorially it's Europe.
Of course. Well, obviously we stick to the European continent at the moment, and obviously we don't ship out to the Caribbean at the moment. So obviously that's our boundaries, and we stick to.
Okay. Now here's an interesting question. If you going back to the technical side of things, if you're, because the 12 volt, usually people are using their starter battery as a protection system for the charger. But if somebody were to switch to 24 volt, would the starter battery still be a good enough buffer to protect the alternator or the starter? Or how do you address that if you're running a pure 24 volt battery bank?
Jess?
Yeah, good question. If you have, let's say, a 12 volt alternator connected to a 12 volt starter battery, and then you have some kind of device in between that's going to knock it up to 24 volts to charge the battery bank, is that a sufficient buffer? And with spike back voltage, where's it going to land? That's a good question. And also, is the alternator connected directly to the lithium bank? In that case,
Yeah.
It's like Brian mentioned, you'd want an APD, like an alternator protection device, that's going to act as some kind of buffer or sink. So, yeah, I'm not sure if really that. I'd have to look at the specific scenario and really kind of dig into it to answer that directly.
Mm-hmm. Okay. So, but basically you recommend that in any installation, you should have an APD. And that's independent. It's not that it's a device that's just dumping to your starter battery or anything. It's integrally protecting, buffering the system. Is that correct?
Yeah, in general, yeah. I mean, if you're worried about high voltage spike back, you're cutting off any kind of high amperage load, and you're going to get potentially that spike back, that's the device to have. You can use a buffer in a starter battery, which is fine. But you know, it really depends on the individual setup, and everybody's system can be a little different. But yeah, in general, APD is what we recommend.
Mm-hmm. Okay. I think, Brian, didn't you guys do a video that really went in detail about a schematic analysis of your install?
Yeah, we did, and somebody actually did something really cool. They made like a proper diagram, because I think mine was sort of hand sketched out, which was really nice. I could send that to everybody if they're interested, or I could send it to you, Tito, and you could disperse it if you want. Or
yeah, I think that would be great. If you just send that to me or to Bill, we can get that out on the system so that it's
okay.
You know, it's available.
Well, I have I think I have
good.
Bill's email address, so I can just send it through to him then.
Go ahead. Yeah, that's great. Okay, and so yeah, and then this is, Courtney was asking, so what would be the advantage of going with a 24-volt cell versus 12 volts in the Amels? Is there any pronounced difference going with 24 volts in that sense?
No, I think there's positives and negatives to either 12 or 24. You know, 24 volts in parallel, you may not have to worry about balancing as much, you know, if that is indeed an issue. The 24 volts are a little bit more expensive than the 12 volts, so there's a disadvantage, you know. They're both going to work electrically really well. So outside of that, it's kind of an individual choice what you want to do. Spend a little bit more money, have something in parallel, have the 100 amp hours, save a little bit of money, and make sure you're keeping your bank topped off.
Okay, yeah, I mean, and Ken brought up a good point that if your starter battery does go and you've got a 24 volt, how do you deal with that? So with a 12 volt, with a bank of 12 volt batteries, you could, in theory, jump off of one of those. So
Correct.
that seems like a very interesting system. And then Brian also pointed out that the advantage to, you know, the nice thing about the system is that it's a direct drop in. He didn't have to change anything about the wiring inside the battery compartment. And so that was the advantage of going with the 12 volts there.
You know, there's also, come to think of it, a little bit of more of a discharge rate in the 24 volt as opposed to the 12. If you look at a 50 amp hour battery 24 volt, you have a 60 amp continuous discharge rate. You put two of those together, you have 120 available if you need some kind of higher discharge, as opposed to two 100 amps in series, you only get about 100 of deliverables. So as a side note, sorry, I just thought about that.
Okay, interesting. Okay, and so I'm just checking the boards here. Does anybody have any other questions? Well, I think that we've had a good session here. Really, really good. I just before I hand it back to Bill, and what I wanted to do is I will see if I can extract from the transcript of this recording a text version of the Q&A, and that way we'll see about extracting that and putting that up as a series of Q&A responses. And
yeah,
so I think
very good.
it's going to be good. So Bill, I'll hand it off to you.
Okay, I just have a couple of things to say. Brian, thanks a lot for joining us. Jesse and Justin, it's a great presentation. It's a good product. I really appreciate it. One thing for Jesse and Justin, if there is something that you would like to present one time to the 1,100 owners of the Amel group, send it to me and I will post it so the people, not only the people that were in this meeting, but all of the Amel owners will have it. So if you want to do that, the door is open. So get that to me, and I promise you to get it to 1,100 people. So thanks again. I really appreciate it. It was a good meeting.
Thanks for having us. Really, seriously,
Thanks.
it's great.
Thanks, guys.
Thanks, Brian.
Now I get to finish repairing my washing machine. Never ends.
Hey, Brian, maybe I can help you with that remotely.
It's a South African one. I don't know.
Oh, I don't know. I repaired the Thompson a lot of times.
Did you?
Yeah.
I'll let you know. I'm deep into it though. I'm almost there, I think. Yeah.
Have your own Zoom.
Thanks, guys. Been a real pleasure. Have a good one. Enjoy your weekend. Bye.
Thanks, you guys.
Thank you, everybody. You did a great job. Okay, yeah. So terrific. Okay, well, thank you very much, everybody. We will look forward to seeing everybody for the next meetings that we're having. Good seeing you all. Bye-bye.